Hey, welcome to the 30th session of the Flipped Classroom for AP Calc. Uh, this session is coming to you from snow-covered northern Wisconsin, as I'm trying to do it between cross-country skiing and doing some schoolwork. Today we're going to talk about integral rules and specifically integration by substitution. Okay, it's pretty simple, so see if you can follow along. There's some basic integral rules that are similar to the rules that we had for derivatives, and let's just go over them. The first is the constant multiple rule, and it says that the integral of k times some function f of x dx is equal to k times the integral of f of x dx. So you can just pull a constant to the outside. The next one is rules for negatives, and it's similar to the constant multiple rule. In fact, it's actually the same rule. It says if there's a negative in front of the f of x, you can pull the negative sign to the outside. And the last rule is the sum and difference rule, which says that the integral of the sum of two functions, f of x plus or minus g of x, is simply equal to the individual integrals, the integral of f of x plus or minus the integral of g of x. Okay, that's it. So here's an example. If we have the integral of x squared minus 2x plus 5 dx, it means that you can separate those if you'd like and just take the individual integrals or just integrate it straight across the board. So I would get x cubed over 3 minus 2x squared over 2, which actually reduces to x squared plus 5x plus c. And that would be using the sum or difference rule. Now there's some special integrals, the integral of sine squared of x and cosine squared of x, that are easy to find, but you have to recognize you need to use a trig identity first. So to find the integral of sine squared of x, we're going to use the trig identity sine squared of x equals 1 minus the cosine of 2x, all of that over 2. So now, if we just rewrite that integral, the integral of sine squared of x dx, to be the integral of 1/2 1 minus cosine of 2x dx, pull the 1/2 to the outside because that's our k, and take the integral of the sum, I get it equals 1/2, the integral of 1 would be x, and the integral of cosine of 2x would be negative 1/2 sine of 2x plus c. So we're looking at x distributing the 1/2, we're looking at x over 2 minus the sine of 2x over 4, because there's another 1/2 in front of the sine of 2x plus c. So the integral of the integral of sine squared of x simply equals x over 2 minus the sine of 2x over 4 plus c. What about the integral of cosine squared of x? Well, we use another trig identity that says cosine squared of x is equal to 1 plus the cosine of 2x over 2. And I have substituted that in here. You can see right here I've substituted it in. We're going to take the integral of that, and I sort of skipped a step here, I apologize, but we have that the integral of that would be x plus 1/2 sine of 2x, all multiplied by 1/2 because we're going to pull the 1/2 to the outside. And that simplifies into x over 2 plus sine of 2x over 4. So sorry about that. So the only difference between these two integrals, actually, if you look at it, is the minus sign and the plus sign. So that's kind of easy to remember. Substitution method of integration. This method is sometimes called U substitution and is used for taking the integral of composite functions. Here we have clearly a composite function, the integral of cosine of 7x plus 5 dx. Step 1, let's let U represent our inside function, 7x plus 5. If we take the derivative of that with respect to x and then write it as a differential equation, we get du equals 7 dx. Solving this for dx, we get dx equals 1/7 du. Okay, so now I'm going to rewrite the original integral in terms of u and take the integral. So I would get the integral of 1/7 cosine u du. Notice the 1/7 du is what dx is, so I just replace dx with that, and the cosine I replace 7x plus 5 with u. Now I can easily take this integral, pull the 1/7 to the outside, that's our constant multiple rule, take the integral with respect to u of cosine of u, and that would be 1/7 sine of u plus c. There's only one problem, that our integral needs to be in terms of x. So what we're going to do is we're going to do what they call back substitute x in for u. And when we do that, remember u was 7x plus 5, so when we back substitute x in for u, I get 1/7 sine, here's my u, 7x plus 5 plus c, and that's what y would equal. Of course, you can always check this by taking the derivative, and you should end up with the integrand way up here, and you do. Okay, let's try another one. This time we have the integral of 2x over x squared plus 1 to the 1/3 dx. That dx is in the numerator. That's sort of important. I'm going to let u be x squared plus 1. Why do I choose that for u? Because I know when I take the derivative, I have the 2x already in the problem, and that's going to let me neatly substitute du in terms of x. So du is 2x dx. Substituting what du is, you can see I have a 2x here, and I have the dx there, so that's going to be my u, so I can rewrite this integral as the integral of u to the negative 1/3. I brought the 1/3 up top and made it negative, du. Now we can take the integral of that, which would be 3/2 u to the 2/3 plus c, substitute x back in for u, we get y equals 3/2, here's my u, x squared plus 1 to the 2/3 plus c. Pretty simple. One more, okay? This time we have the integral of 2x dx over x squared minus 5. What do you think you're going to let u be? Well, again, using the same reasoning, I see I have a 2x in the top. I know that when I take the derivative of u, I get 2x, so that looks like a good way to go. Take the derivative of x squared minus 5 with respect to x, write it as a differential, I get 2 du equals 2x dx. Notice, here's my 2x dx, so that's going to be du. Rewrite this problem as the integral of du over u. Okay, so now you got to ask yourself, what has a derivative of 1 over u? Well, that would be the natural log of u. Okay, so the integral of du over u is simply the natural log of u plus c. Why is u an absolute value sign? Because you cannot take the natural log of a negative number, and sometimes if u was negative, you would have to make that positive. So we have to have an absolute value sign in front of whatever we're taking the natural log of. Okay? And then we're going to substitute for x in for u, so we get y equals the natural log. Here's our u, x squared minus 5, absolute value, just in case that comes out to be negative, plus c. Not too bad, right? Alright, this is a rather large homework assignment, so if you have time today and you're watching the video, you might want to start on it, even though we have not had the quiz on section 4.1 part 2 yet. These problems go pretty quickly, but there's no word problems, or actually there's two, 59 and 60, but they're pretty simple. Okay? Enjoy the rest of your day.